Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 28, 2025, which was just yesterday. The headline result is clear. A task-centric instruction augmentation method delivers an average improvement of 8.7% on 4 real-world, task-specific applications without hurting general instruction following. The paper is titled TCIA, a task-centric instruction augmentation method for instruction fine-tuning. And as we will see later, the implications for deploying focused models are quite significant. In short, the method expands instructions while keeping them tightly on task by decomposing prompts into a query and constraints, and then augmenting them in a controlled way. Alright, the introduction just laid out the promise and the challenge. Figure 1 shows side-by-side distributions of instruction diversity over hops and a line plot of on-task ratios. The blue curves stay high and tight across hops, which means TCIA keeps diversity, while Wizard LM drifts toward repetitive patterns. The line plot indicates near 100% on task coverage for TCIA, while Wizard LM declines steadily as hops increase, so augmentation stays relevant without sacrificing variety. So Figure 2 lays out the 6-step pipeline that makes the augmentation both diverse and on task. The graphic shows decomposition into a base query and explicit constraints, retrieval from an instruction database, and a breadth-first search that adds, removes, or replaces constraints to explore variants. The pipeline then converts states back to natural instructions, validates them with context, and samples responses from multiple models, which are judged across 5 dimensions before storage for supervised fine-tuning. This end-to-end flow matters because each gate preserves task relevance while still expanding variety. Okay, the pipeline just showed how decomposition drives retrieval and search. Table 1 presents concrete decompositions that split each original instruction into a base query and explicit constraints, which makes the requirements auditable and machine actionable. The first row shows the travel ad prompt turning into a concise query plus 3 constraints about content and length. The second row converts a summarization template into a query with bullet point, source limited, and clarity constraints, while the third row isolates the longest common substring task as a clean query. Well, the table just highlighted constraint generalization gaps. Figure 3 shows end-to-end performance across 4 in-house tasks, and the orange bars lead in every panel. The gains are sizable because task-centric augmentation keeps instructions diverse yet on task. Task A reaches about 60.2, Task B about 80.5, Task C about 82.4, and Task D about 79.3. The method also edges past GPT-4o and beats Wizard LM and Fixed Instruct consistently, which signals robust, transferable task understanding. Wrapping up, 2 takeaways stand out. Task-centric augmentation that decomposes prompts into a query and constraints keeps diversity high while staying on task, and the approach delivers tangible gains, about 8.7% on proprietary tasks, without hurting general ability. The broader implication is clearer pathways to focused, reliable deployments. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.